All right, so we are on Charles' Law, and so this is on page 14 of your packet. All right, and this is number 4. All right, so Charles' Law number 4, page 14 in your packet. So again, as we're looking through this problem, make sure you write down what variables you're looking at. So 250 milliliter volume. All right, so this is going to be a V. Remember, we always want to convert everything to liters. So 0.250 liters. All I did was move that decimal point 3 spots to give me my liters. Okay? Of gas is collected at 333 kelvins. Now, kelvins is temperature. All right? And those would go together. So these are going to be our ones. So 330 Kelvin. And as you notice that I don't necessarily put those right away. I kind of look to see what else I have. And then it says what temperature. All right, so what temperature? That's asking us that. So we're going to figure out what that is. Would this sample gas have if it occupies a volume of 226 milliliters? So my V2 is going to be 0.226 liters. All right. So now you guys know as temperature increases, volume increases. As temperature decreases, volume decreases. So they are directly related. And anytime you have a directly related scenario, those two things are always divided. Okay? So our V1 over T1 is going to equal V2 over T2. Okay? And again, if you don't know those, then go and memorize them. Make flashcards. Do something so that you know those laws. Okay? So we're looking for our T2. So my first step is to cross multiply. All right, so I'm going to have my V1 times T2 equals V2 times my T1. All right, and we are looking for this right here. So T2, I'm going to divide both sides by V1. Okay, so I need to have this in my problem. I need to have this in my problem. The next thing I'm going to do is plug in my numbers. So my V2, 0.226 liters times T1, okay, all divided by my V1, okay, and plug it into our calculator. All right, so I am going to get 298 Kelvin. All right, and that should make sense because our liters is getting smaller. Temperature is directly related, so it is getting smaller. We know we've done it correctly, okay, or we're on the right track. All right, and